Hello and welcome back to the session on the CIS controls. In this lesson we will continue on to Control 16, Application Software Security, and the 14 safeguards within this control. This control focuses on the secure development, management and maintenance of application software, whether developed internally by third parties or acquired commercially. The goal is to ensure that security is built into applications throughout their lifecycle, from initial design to deployment and ongoing support. This control addresses practices such as integrating security into the software development lifecycle, or SDLC, using secure coding standards and tools, performing code reviews and vulnerability assessments, managing third-party software components and open source libraries, ensuring applications are properly maintained and updated. Why is this control important? Applications are a frequent target for cyber attacks, with vulnerabilities in software often exploited to gain unauthorized access, steal data, or disrupt operations. Without secure coding and testing practices, organizations risk deploying applications that become weak points in their cybersecurity posture. Key benefits of this control are as follows. Reduces the number of vulnerabilities introduced during development, ensures timely patching and maintenance of applications, increases resilience against attacks like SQL injection, cross-site scripting, and remote code execution, helps meet compliance requirements related to software security, promotes collaboration between development, security and operations teams. You should adopt DevSecOps principles, or development, security and operations principles, to integrate security into every phase of the development pipeline and use automated tools for continuous testing and monitoring. Let's start learning about each of the safeguards within Control 16. Safeguard 16.1, establish and maintain a secure application development process, comes under the Govern Security function and is within Implementation Group 2. This safeguard requires organizations to develop, document and maintain a formal process for secure application development. The goal is to integrate security into every stage of the software development lifecycle, or SDLC, ensuring that both in-house and third-party applications are built with security in mind from the start. The secure development process should include secure application design standards, secure coding guidelines and frameworks, regular developer security training, vulnerability identification and remediation procedures, policies for evaluating and using third-party or open source code, security testing methods such as static and dynamic analysis. Why is the safeguard important? Poorly designed or coded applications often introduce vulnerabilities that can be exploited by attackers. By embedding security into the development process, organizations can prevent security flaws early when they are easier and cheaper to fix, reduce the risk of data breaches or system compromises, ensure consistency and quality across all development efforts, comply with regulatory and industry standards related to software security. Possible tools to help include Secure Software Development Lifecycle, or SSDLC frameworks, such as Microsoft SDL, NIST Secure SDLC, OWASP SAM, or Software Assurance Maturity Model. Secure coding standards, such as OWASP Secure Coding Practices, SEI Cert Coding Standards. Developer security training platforms such as Secure Code Warrior, Hack EDU, Veracode Security Labs. Application security policies and standards such as a secure development policy, secure code guidelines and third-party code approval processes. Secure DevOps or DevSecOps processes such as GitLab CI/CD with integrated SAST and SCA, Jenkins pipelines with security plugins, and annual policy and process review procedures. Other tools that may assist include code review and static analysis tools, dynamic application security testing or DAST tools, software composition analysis or SCA tools, vulnerability management and issue tracking systems. Safeguard 16.2, establish and maintain a process to accept and address software vulnerabilities, comes under the Govern Security function and is within Implementation Group 2. The safeguard requires organizations to establish and maintain a formal vulnerability disclosure and handling process for internally developed or managed software. It ensures there is a consistent way to receive, assess, and remediate software vulnerabilities, especially those discovered by external entities like researchers or customers. The process should include the following: a public-facing method for submitting vulnerability reports, for example, email or a web form, a defined vulnerability management policy, including roles and responsibilities, a structured workflow for intake, triage, assignment, remediation and testing, a vulnerability tracking system to monitor progress, severity levels and response timelines, and periodic review and updating of documentation. Why is the safeguard important? Having a clear process to accept and address vulnerabilities helps organizations to respond quickly to security flaws before attackers can exploit them, build trust with external researchers and users by demonstrating transparency, meet expectations for responsible disclosure in regulatory and industry frameworks, and minimize the risk of data breaches, system compromise, or reputational damage. Possible tools to help with this safeguard include Vulnerability Disclosure Policy, or VDP, a Vulnerability Handling Policy, bug bounty platforms or responsible disclosure channels such as HackerOne, BugCrowd, Open Bug Bounty, or self-hosted disclosure pages, vulnerability tracking and ticketing systems such as Jira, GitHub Issues, Azure DevOps, ServiceNow, secure communication channels for external reporting such as PGP encrypted email, web submission forms, or a security text file on the website, severity rating and scoring tools such as provided from CVSS or the Common Vulnerability Scoring System, or EPSS, Exploit Prediction Scoring System, metrics and reporting dashboards, secure software development lifecycle integration, and annual review and update procedures. Safeguard 16.3, perform root cause analysis on security vulnerabilities, comes under the Protect Security function and is within Implementation Group 2. The safeguard requires organizations to go beyond fixing individual software vulnerabilities by conducting root cause analysis, or RCA. The goal is to identify and understand the underlying reasons why vulnerabilities occurred in the first place, such as insecure coding practices, design flaws, lack of developer training, or process gaps. Root cause analysis helps development teams answer questions like, what led to this vulnerability? Was it preventable? Are similar flaws present elsewhere in the codebase? And how can future occurrences be avoided? Why is the safeguard important? Focusing solely on patching individual issues leads to a reactive security approach. By performing RCA, organizations can systematically reduce recurring security issues and improve the maturity of their development lifecycle. It enables better prevention of similar future vulnerabilities, improvements to development processes, tools or training, and higher quality, more secure software overall. Possible tools to help include RCA frameworks and templates such as common models from 5 Whys, fishbone diagram, fault tree analysis, issue tracking systems such as Jira, GitHub Issues, Azure DevOps, ServiceNow, vulnerability scanning and analysis tools such as Veracode, Checkmarx, Fortify, OWASP Zap, SonarQube, secure code review tools such as GitHub Code Scanning, CodeQL, SemGrep, ESLint for JavaScript, knowledge management and RCA knowledge base, for example SharePoint and Notion, developer and security team collaboration tools such as Slack, Microsoft Teams, Miro, training and process improvement feedback loops, for example Secure Code Warrior, HackEDU, integration with DevSecOps pipelines including Jenkins, GitLab CI/CD with vulnerability reporting features, and RCA reporting metrics and dashboards. Safeguard 16.4, establish and manage an inventory of third-party software components. Comes under the Identify Security function and is within Implementation Group 2. The safeguard requires organizations to create and maintain an inventory of all third-party software components used during application development. This list, often called a Software Bill of Materials or SBOM, should include both current and planned components and must document any associated security risks, such as known vulnerabilities or end-of-life status. The inventory should be reviewed regularly, at least monthly, used to verify components are still supported and maintained, and integrated into the development and procurement process. Why is this safeguard important? Third-party software components, such as open source libraries and frameworks, can introduce hidden vulnerabilities into an application. Without a clear and current inventory, teams may use outdated or unsupported components. Known security issues may go undetected. There's limited visibility into supply chain risks. Maintaining an accurate SBOM allows for faster identification of affected components when new vulnerabilities for example log for shell, are disclosed. Proactive patching and risk mitigation, and improved compliance with emerging regulations and industry standards, for example Executive Order 14028 or NIST guidance. Possible tools to help include software composition analysis or SCA tools such as SNCC, Black Duck, Sonatype, Nexus Lifecycle, WhiteSource, FOSSA, SBOM generators and standards such as SPDX, CycloneDX, SIFT, dependency management tools such as NPM for JavaScript, pip for Python, Maven for Java, NuGet for .NET, CI/CD integration such as GitLab CI, GitHub Actions, Jenkins, Azure DevOps, vulnerability databases and feeds such as the National Vulnerability Database or NVD, OSS Index and CVE details, policy enforcement platforms such as JFrog X-Ray, Artifactory, Sonatype, Nexus Repository with IQ Server, inventory and configuration management systems such as CMDB tools, internal asset tracking tools, SBOM repositories, and monthly review workflows. Safeguard 16.5, use up-to-date and trusted third-party software components, comes under the Protect Security function and is within Implementation Group 2. The safeguard emphasizes the importance of using up-to-date, secure, and trusted third-party software components during the software development lifecycle. These components include libraries, frameworks, and modules, are often critical to development processes but can also introduce vulnerabilities if not carefully selected or maintained. To protect against these risks, it is important to ensure that third-party software components come from reputable and established vendors or open source repositories that are actively maintained. Regularly assess third-party components for known vulnerabilities, for example via security scanning tools, before integrating them into your systems, and to keep all third-party components up to date as vulnerabilities may be discovered over time and security patches or updates may be released. Why is this safeguard important? Using outdated or untrusted components increases the risk of introducing security vulnerabilities, potentially giving attackers a backdoor to exploit. Up-to-date components ensure that the latest security patches are included, reducing the risk from known vulnerabilities. The integrity of third-party components is essential to maintaining the overall security of the software supply chain. Failure to verify components could allow malicious code to be embedded into applications, and many regulatory frameworks and industry standards require the use of secure software components, making compliance easier by following secure development practices. Possible tools to help include dependency scanning tools such as SNCC or WhiteSource, software composition analysis tools like Black Duck, Sonatype, Nexus, vulnerability management tools such as Qualys or Tenable.io, secure code repositories such as GitHub and GitLab, patch management tools such as Avanti or ManageEngine, vulnerability databases such as CVE or NVD, and supply chain management tools such as InToto or TUF. Safeguard 16.6, establish and maintain a severity rating system and process for application vulnerabilities. Comes under the Govern Security function and is within Implementation Group 2. The safeguard requires organizations to define and consistently apply a severity rating system for vulnerabilities found in application code. The system should be used to prioritize remediation efforts, ensuring that the most critical issues are addressed first. The process should also define minimum acceptable security thresholds for software before it can be released. Key components include a structured vulnerability severity rating system, for example CVSS, clear criteria for triaging and prioritizing vulnerabilities, defined remediation timelines based on severity, security gates or release thresholds for applications, and an annual review of the system and process. Why is the safeguard important? It allows organizations to focus on fixing high-impact vulnerabilities first, reducing risk exposure, provides a standardized process, ensures that all teams respond to vulnerabilities in a predictable, policy-driven way. It ensures that insecure code doesn't go live by enforcing security standards at release checkpoints. And it provides visibility into how vulnerabilities are handled, prioritized, and remediated. Possible tools to help include vulnerability scoring cards such as CVSS, static application security testing or SAST tools such as SonarQube, Checkmarx, Fortify, Dynamic Application Security Testing or DAST tools such as OWASP Zap, Burp Suite Pro, Acunetics. Software Composition Analysis or SCA tools such as SNCC, Black Duck, Mend. Vulnerability Management Platforms such as Qualys, Tenable.io, Rapid7 Insight VM. Issue Tracking and DevOps tools such as Jira, Azure DevOps, GitHub Issues. Security governance documents may include items such as a vulnerability management policy, secure software development lifecycle guide, risk management frameworks, remediation timelines matrix, and severity rating review process. Safeguard 16.7 Use standard hardening configuration templates for application infrastructure. Comes under the Protect Security function and is within Implementation Group 2. The safeguard requires organizations to apply standardized hardening templates to all application infrastructure components, such as servers, databases, web servers, containers, and cloud environments, to minimize security vulnerabilities. Hardening involves removing unnecessary services, securely configuring settings, and enforcing least privilege. The use of industry-recognized baselines, such as those from the Center for Internet Security, or CIS benchmarks, or vendor-recommended configurations, ensures consistency, reduces misconfiguration risks, and strengthens the organization's overall security posture. Importantly, this safeguard also cautions that custom or in-house developed software must not override or weaken these hardened configurations. Why is the safeguard important? 1. Reduces attack surface. Removes default settings, unnecessary ports, and services that attackers often target. 2. Standardizes security practices. This ensures consistency across systems and environments. 3. Mitigates human error. Using templates reduces manual misconfigurations that could create vulnerabilities. 4. Enhances compliance. Aligns with best practice and audit requirements for secure system configurations. And 5. Supports secure DevOps. Integrating hardened templates into development pipelines ensures secure infrastructure from the start. Possible tools to help include configuration baseline frameworks with tools such as CIS benchmarks, DISA STIGs, which is the Security Technical Implementation Guides, Infrastructure as Code or IAC tools such as Terraform, AWS CloudFormation, Azure Resource Manager templates, Ansible, Chef, Puppet, hardening verification tools such as OpenSCAP and Linus, cloud security tools such as AWS Config plus AWS Security Hub, Microsoft Defender for Cloud, Google Cloud Security Command Center, container hardening tools such as Docker Bench for security, KubeBench for Kubernetes, and policy enforcement tools such as OS Query and Group Policy Objects. Safeguard 16.8 Separate production and non-production systems. Comes under the Protect Security function and is within Implementation Group 2. The safeguard requires organizations to maintain strict separation between production and non-production environments, such as development, testing, and staging systems. Each environment should be isolated physically or logically to prevent unauthorized access, accidental changes, or data leakage from affecting live production systems. Non-production environments are often less secure and are used more freely by developers and testers. If these environments are not adequately separated, vulnerabilities or misconfigurations could lead to data exposure, unauthorized access, or disruption of critical services. Why is this safeguard important? It helps prevent errors in testing or development environments from impacting production data or services, ensures sensitive production data isn't exposed in less secure non-production environments, enables different access permissions for developers, testers, and operations teams. Regulatory frameworks often require environment separation for sensitive systems, and reduces the chance of malicious code or vulnerabilities migrating between environments. Possible tools to help include virtualization and cloud resource management, such as VMware vSphere, Microsoft Hyper-V, Proxmox, AWS organizations, Azure management groups, Google Cloud projects, network separation tools, such as firewalls, for example, Palo Alto, Fortinet, Cisco ASA, software-defined networking, or SDN, and tools like NSXT or Azure Virtual Network Manager. Infrastructure as Code, or IAC tools such as Terraform, Pulumi, AWS CloudFormation, Azure ARM templates, CI/CD pipeline tools with environment controls such as GitLab CI/CD, Jenkins, Azure DevOps, GitHub Actions, IAM tools such as AWS IAM, Entra ID, Google Cloud IAM, PAM tools such as CyberArk Beyond Trust or Delinear, previously Thiocotic, data masking and synthetic data tools such as Informatica, Delphix, Redgate Data Masker, environment monitoring and policy enforcement such as HashiCorp Sentinel, OPA or Open Policy Agent. Safeguard 16.9, train developers in application security concepts and secure coding, comes under the Protect Security function and is within Implementation Group 2. The safeguard requires organizations to ensure that all software developers receive formal training on secure coding and application security practices relevant to their roles and technologies. The goal is to equip developers with the knowledge to identify, prevent, and mitigate common security vulnerabilities during the development process. Training should be conducted at least annually and tailored to the technologies and environments developers use. This includes covering secure design principles, OWASP Top 10 vulnerabilities, threat modeling, and secure development lifecycle or SDLC practices. The safeguard also aims to build a culture of security awareness within the development team, encouraging developers to treat security as a shared responsibility and integrate it into their daily workflows. Why this safeguard is important: it prevents common coding flaws such as SQL injection, cross-site scripting or XSS, or broken authentication from being introduced into applications, reduces the cost and impact of vulnerabilities by addressing them early in the software development lifecycle, promotes a proactive security mindset and shared accountability within development teams, supports compliance with regulatory and contractual security training requirements, and helps align development practices with recognized secure coding standards and frameworks. Possible tools to help include secure coding training platforms such as Secure Code Warrior, HackEDU, and Contra, general developer training platforms such as Pluralsight, Udemy Business, and LinkedIn Learning, open source simulation environments such as OWASP WebGoat, JuiceShop, and Security Shepherd, internal security knowledge sharing tools like Confluence, Notion, or SharePoint, micro-learning and LMS integration such as Codebashing, AppSec, LMS platforms, and traditional corporate LMS systems, threat modeling and secure design tools such as Microsoft Threat Modeling Tool, OWASP Threat Dragon, or custom checklists, and progress tracking and reporting. Safeguard 16.10, apply secure design principles in application architecture, comes under the Protect Security function and is within Implementation Group 2. This safeguard emphasizes integrating secure design principles into the application's architecture. These principles are designed to minimize vulnerabilities by ensuring that security is built into the application's design from the very beginning. Key concepts include the principle of least privilege, input validation, and minimizing attack surface by eliminating unnecessary services or programs. Why is the safeguard important? The safeguard is essential because vulnerabilities introduced during the design phase can lead to serious security issues that are difficult and costly to fix later. By proactively applying secure design principles, organizations can reduce the potential for unauthorized access, data breaches, and system compromise. Least privilege and input validation ensure that the application only allows authorized users to perform authorized actions while securing the system from malicious inputs or attacks like SQL injection, buffer overflows, or unauthorized access. Possible tools to help include static application security testing or SAS tools such as Checkmarx, Veracode, Fortify, SonarCube, dynamic application security testing or DAST tools such as Acunetics, NetSparker, IBM AppScan, web application firewalls or WAFs such as Cloudflare WAF, AWS WAF, Mod Security, secure configuration management tools such as Chef, Puppet, Ansible, SaltStack, IAM solutions such as Okta, Entra ID, Ping Identity, input validation libraries such as OWASP ES API, Validator.js, and Apache Commons Validator, error handling frameworks such as Logback, Sentry, ELK Stack. ELK is Elasticsearch, Logstash, and Kibana. Container security tools such as Docker Bench for Security, Aqua Security, Twistlock. Security development training tools such as Secure Code Warrior, Pluralsight, Cybrary, OWASP training, and penetration testing tools such as Burp Suite, Kali Linux, Metasploit, or Wireshark. Safeguard 16.11, leverage vetted modules or services for application security components, comes under the Identify Security function and is within Implementation Group 2. This safeguard emphasizes the importance of using trusted, pre-built and vetted application security modules or services for critical security functions such as identity management, encryption, auditing, and logging. Rather than building these components from scratch, Organizations should rely on platform features or services that have been extensively tested, reviewed, and standardized. This approach minimizes the potential for errors in the design and implementation of security controls, ensuring a more secure and efficient application infrastructure. Leveraging vetted services and modules reduces the developer's workload, freeing them up to focus on other areas of the application while also benefiting from industry-tested security mechanisms. For example, modern operating systems often offer integrated identity, authentication, and authorization services, as well as secure logging and auditing capabilities, which should be utilized instead of developing custom solutions. Why is the safeguard important? Pre-built, trusted components reduce the need for custom development, accelerating the application development process and allowing developers to focus on other features. By utilizing widely recognized security practices, for example, trusted encryption algorithms, identity management, secure logging, organizations can ensure their applications meet industry standards and security requirements. And leveraging operating system features for identity management and audit logging ensures that these critical components are implemented correctly and securely, enhancing the overall security of the application. Possible tools to help include IAM tools such as Active Directory, Entra ID, Okta, LDAP, Keycloak, encryption libraries and services such as OpenSSL, AWS KMS, Azure Key Vault, Google Cloud Key Management, Bouncy Castle, Microsoft Crypto API, audit and logging services such as AWS CloudTrail, Azure Monitor, and Azure Security Center, Splunk, ELK Stack, Greylog, security frameworks and APIs such as OAuth 2.0, OpenID Connect, SAML or Security Assertion Markup Language, and JSON Web Tokens or JWTs, and security testing tools such as OWASP Zap, Burp Suite, SonarQube. Safeguard 16.12 Implement code level security checks. Comes under the Protect Security function and is within Implementation Group 3. The safeguard focuses on integrating security into the software development lifecycle by applying static and dynamic analysis tools to ensure that secure coding practices are followed throughout the development process. These tools help identify vulnerabilities in code early in the development process, both before the code is run, or static analysis, and during runtime, or dynamic analysis. Static analysis tools inspect the source code or binaries of an application for potential vulnerabilities, security misconfigurations, or deviations from secure coding standards without executing the code. Dynamic analysis tools test the running application, checking for security issues that can only be detected while the application is running, such as input validation issues, memory leaks, or runtime vulnerabilities. By incorporating these security checks into the development lifecycle, organizations can identify and address vulnerabilities before the software is deployed, reducing the likelihood of security breaches. Additionally, this approach helps developers adhere to secure coding practices, improving the overall security posture of applications. Why is this safeguard important? It detects vulnerabilities early in the software development lifecycle, reducing the cost and effort needed for remediation, ensures that applications are designed and developed with security in mind from the start, provides continuous automated security checks as part of the development pipeline, ensuring consistent adherence to security practices, and helps meet security standards and regulations by identifying vulnerabilities early and maintaining secure coding practices. Possible tools to help include SaaS tools such as SonarQube, Checkmarx, Fortify Static Code Analyzer, Veracode, DAST tools such as OWASP Zap, Burp Suite, Acunetics, HCL AppScan, Integrated Development Environment or IDE plugins such as SonarLint, Checkmarx, IDE plugin, Fortify On Demand, CI/CD tools such as Jenkins, GitLab CI, Circle CI, code quality and security monitoring platforms such as GitHub Security Alerts, Codacy, SNCC. Safeguard 16.13 Conduct Application Penetration Testing comes under the Detect Security function and is within Implementation Group 3. The safeguard emphasizes the importance of conducting application penetration testing to identify vulnerabilities in critical applications. Unlike automated security testing, which can miss business logic flaws, penetration testing focuses on manually assessing the application security from both an authenticated and unauthenticated perspective. This process helps detect vulnerabilities that might be exploited by attackers, such as issues in how an application processes input, manages sessions, or enforces access controls. Why is a safeguard important? Penetration testing is crucial because it goes beyond basic vulnerability scanning and automated tools to assess the real-world effectiveness of an application's defenses. Automated testing tools may miss complex vulnerabilities that only a human tester can identify by actively interacting with the application. For critical applications, authenticated penetration testing can reveal issues in how business logic is implemented and exposed, which could potentially allow attackers to bypass security controls or exploit flaws to gain unauthorized access or manipulate data. Conducting regular penetration tests is vital for identifying vulnerabilities before malicious actors can exploit them. Possible tools to help include penetration testing tools such as Burp Suite, OWASP Zap, Metasploit, Acunetic's Nessus, manual penetration testing tools such as Kali Linux or Wireshark, authentication and session management testing tools such as Selenium or Postman, business logic testing such as Burp Suite Intruder and OWASP Web Security Testing Guide, security testing platforms such as Cobalt Strike or Core Impact, security code review tools such as Checkmarks or SonarCube, and reporting and remediation tools such as Jira and Trello. Safeguard 16.14, Conduct Threat Modeling, comes under the Protect Security function and is within Implementation Group 3. The safeguard emphasizes the importance of conducting threat modeling early in the application development lifecycle to identify and mitigate security risks before code is written. It involves analyzing the application design to identify potential vulnerabilities, access points, and weak spots. This process helps organizations evaluate security risks associated with each part of the application, infrastructure, and user access level. Why is this safeguard important? Identifying potential security threats early allows organizations to address weaknesses before any code is developed, reducing the risk of vulnerabilities in the final product. Threat modeling ensures that security is built into the design phase rather than being an afterthought or something to be fixed later in the development process. It fosters a security-first mindset among developers and architects. By assessing security risks up front, organizations can prioritize areas of the application that need extra attention, helping allocate resources effectively and avoid wasting time on non-critical components. Many industries require organizations to implement secure development practices, including threat modeling, to comply with standards like GDPR, PCI DSS, HIPAA, etc. Threat modeling provides a structured way for development, security, and operations teams to communicate about potential security risks and solutions. It helps identify potential threats across different layers of the application and infrastructure. Possible tools to help include the Microsoft Threat Modeling Tool, OWASP Threat Dragon, Arius Risk Threat Modeler, PyTM, SecuriCAD, and Acuity Threat Modeling. In this lesson you have learnt the 14 safeguards included in CIS Control 16, Application Software Security, the implementation group of each safeguard, and possible tools to use within each safeguard. In the next lesson I'll take you into Control 17, Incident Response Management, including the recommended safeguards in this control, the implementation group of the safeguards, and some recommendations on tools you may use to help in implementing these safeguards. I look forward to you joining me in the next lesson as we continue discovering the CIS controls. Thank you.